Now, if you're thinking back to the first problem we did and you're like, "Oh, so, why did we do it that way?" Well, because that is a possibility. We could do problem 3 by expanding it. 1 plus 2x times 1 plus 2x times 1 plus 2x times 1 plus 2x. Foil, 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 foil. Combine like terms, antiderivative. That would work. Do we want to do that? Some of us might prefer to do that rather than U sub, but it's definitely a much longer process, and mathematicians are always looking for shortcuts. So something like this, they're like, I'm not taking that to the 4th power. I mean, holy crap, what if that was a 10? 10th power. I don't want to take that to the 10th power. U substitution lets us bypass that. Now, in this problem, it's a little weird. Well, actually, I have, because you might be thinking, well, wait, I don't really see like enough stuff. But you still have an inside. So that is your U, the thing that's raised to the power. This is a little bit more like the one we started class with. So we're going to do this one, and then we're going to go back and do the first problem with U substitution again, and we're going to see if we get that, well, hopefully, please God, as long as I don't mess up, we should get that 4/3 answer. So here's U. The derivative of that, in terms of x, is just 2. So du is equal to 2 dx. So as I start to do rewriting, this part is my u. So I have u to the 4th. And that's all good, except the only thing else I have is dx. So this is what I have. But in order to make the whole u magic work, I need a 2 dx, not just dx. I need a 2. A 2 and a dx would be perfect. Luckily, I have a math trick that I can do. So here's my trick. I'm going to put a 2 there. That's not a very exciting trick. You're like, okay, you need a 2, you put a 2. Yep. But I can't just go changing problems and make them be what I want them to be. I have to keep the nature of the original problem. So what else could I multiply by that would kind of offset, neutralize multiplying by 2? Let's think about it in certain terms of solving equations. If we wanted to cancel out multiplying by 2, we could divide by 2, right? So multiplying by 2, if we wanted to cancel that out, we would divide by 2. Dividing by 2 is like multiplying by what? Divide by 2 is the same as multiplying by a half. Keep, change, flip. So cutting a half, multiplying by a half, 10 times 1/2 is 5. 10 divided by 2 is 5. Multiplying by 1/2 has the same effect as dividing by 2. So here's what I'm going to do. I'm actually going to add 2 things into this problem. I'm going to write a times 2, because that's what I need. And I'm going to write a times 1/2. And I'm going to use the word neutralize. I don't know if there's another, synonym. Cancel out. Sort of offset. It's like, okay, if I'm going to put something over here, I put something over here to kind of balance it. If I'm going to multiply by 2, multiplying by 2 and multiplying by 1/2 doesn't essentially change the problem. It just makes it look different. It makes it look different. Because then now I can take that part and what I just circled in pink is my du. And then the only other thing I got to do though is I can't just pretend the 1/2 isn't there anymore. So, but usually instead of leaving it inside, I put it on the outside. So the du is the 2dx, and you have the extra 1/2, and that is the rewritten problem. That's the part usually when we use sub that you kind of go, yeah, I don't like that. Feels shady. And you're right, it does. It kind of feels shady because you're changing the problem. But you're doing it in a way that doesn't really change it. You just kind of make it look a little different. You're like, okay, I need a 2. I'll throw a 2 in there. That's cool. As long as I put the 1/2 also, multiplying with a 2 and a 1/2 essentially isn't really changing the problem. It just makes it look different. You're allowed to do this, but the only change you can make is changes with constant factors. So that means I can't throw like a times x in there if I need it, or a times 2x or something like that. And a missing value, a constant factor like a 2 or a 7 or a 2/3 or some other factor that I might need, I can put constant factors in. Any constant factor I put in, I have to also put in that constant factor's reciprocal. And that reciprocal is going to float on the outside. Okay. All right. And then we're ready to do our antiderivative. I have the 1/2. I have u to the 5th over 5 plus c. I would personally make this 1/10. That's just me. But you can leave it as 1/2 and u to the 5th over 5. And 1 plus 2x, back for u. And that's the answer. What was that? 2x plus 3 squared. Okay. So, tell you what, let's do this. Because I said I thought we should go back to the original that first problem we did and try it using u substitution and see if the answer we get ultimately is equivalent to that answer. And I tell you where we can do that. Let's change problem 6. Now I'm wishing I had left us space to do this and I didn't. So let's do this. Let's change problem 6. If you flip over to this page, let's grab problem 6. Let's turn it into this guy, because it's essentially this very similar problem. All right. Try using u substitution on that problem to get the antiderivative, and we'll see if what we end up getting is equivalent to this. I'm going to cheat a little bit to check their equivalency because I don't feel like doing all the algebra, but that's okay. All right, try u substitution on that. Get an antiderivative for that new problem 6, and let's see if what we get is equivalent to what we got when we did it the long way. While you're doing that, I will get ready to check our answer together. this. X cubed plus 6x squared plus c. Oh, I can't. We'll just leave the c off. Okay. All right. All right, I'm going to work through it. I'm going to do it kind of quietly. So if you just want to try to check what you're doing. When I do U substitution problems, I literally write down all of these things that we're writing in our notes. So, and this is exactly how I teach it to AP Calc kids. I'm like, all right, write down your U. This is how they have to do it also. Show your DU. I tend to do a lot of these with 2's, so I think we do get quite a few with 2's and 1/2s. That became DU, that became U. Oops. 1/3. 2x minus 3. Oh, it's a plus though. Kind of doing stupid stuff like that. That's what's going to make us not have the exact same answer. All right. So if you can, try to do this without copying mine as much. See if you can, because that's going to be the thing. Like a lot of things we do, you watch me, I'm doing the thinking. You're like, yep, gotcha. And then I'm not doing the thinking anymore, and you're like, ooh, I don't like this. It's not a, oh, crap. I made a mistake. I forgot about the half. So the half is there, and then there's a third, or a divide by 3 from the antiderivative. So, and I found this out by trying to check my answer. Yeah, there we go. And that doesn't look like a 6, that looked like a B. All right, let's check that out. I'm super glad I typed this in before right? Plus divided by 3. So a half. Sorry, I was just a little bit too excited. Okay. All right, let me pop over here. Hopefully you were okay with, you threw the 2 in to make the U substitution work, which meant you also had to have the 1/2. Super easy to forget about that extra 1/2. I did it as I was working through. You need to make sure it goes along for the ride. So the U squared becoming the 1/3 U cubed. So when I simplify it kind of all together, the 1/2 and the 1/3 give me a 1/6. And I have this quantity cubed plus c. Now, if you remember, I'm going to turn this off for a second. And we're going to pull this over here. So this is in the recording as well. So there in red is the antiderivative we found by expanding and then doing each piece. So it's blah, blah, blah plus c. We don't know what c is. So, you know, different numbers for c would just take this graph and move it up or down. And here is what we just got. And it would also have a plus c. I don't know if it'll let me do a plus c, a different plus c. Okay. It won't let me slide that, I don't think. Oh, because it's just going to use, let me see how this works. I don't know. Oh, okay. Yeah, it's going to keep this. I can't do that. Can I do it with a different letter? Yes. Okay. All right. So I have to use a different letter because Desmos won't let me like do c sub 1 and c sub 2. So these two functions, if we align them right, I know it looks a little weird, but it's the whole idea. You know, if we expanded this out, this would already have a quantity. There's some magic number here, and maybe it's even better for me just to take that off. But the idea is these guys are identical. They're identical just based on a different constant. The constant, the way it's written here, and the constant, the way it's written here, would be a different number, because if I expanded this out, I would have another number to put with that d. But using the sliders shows that these are, in fact, other than the number out at the end, which is what I'm changing when I move the slider, they're the exact same function. So what we got the long way, which wasn't that long, and what we got the u sub way, they're the same function. They are the same function apart from the c. I do want to save this. Hang on a second, let me save this for a second. Hopefully it'll just let me use an example. I didn't think to do this yesterday in 7th period, and so we were like expanding it to show that they were the same, and that was just like, I was like, blah, that sucked. Okay. So, it's possible to have not just to have the missing number, but still have kind of a variable there. So if we look at example 4 as kind of the last one we're going to do together, this is going to be another one where we're going to have to throw in we're going to have to throw a number in. When we look at the stuff, hopefully you're right now, you're kind of getting good at that, and you're like, okay, I got you. U is 9 plus x squared. And so the derivative with respect to u, the derivative of that is 2x. And so if I do the cross multiplying, I need, once again, off by a factor of 2, I need 2x dx to make everybody work, to make everything work, and I don't quite have that. I have the x, and I have the dx, I just don't have the constant of 2. All right, see if you can finish number 4. Putting in the constant you need, putting in the offsetting value, the reciprocal value to help balance it, doing the antiderivative, and looking and then rewriting it back as x.